Okay, so this is just the Google Earth Practical, so we'll just work through the PDF and the questions. So you're going to have opened up Google Earth here. You can see as you rotate, it rotates the globe. You can zoom in or out with this plus and minus, but also with your scroll bar on your mouse. So if you go File, Open, you can add the KMZ files for this tutorial. So here's the KMZ files. And as they're loading, Google Earth puts them under temporary places. So next time you if you close Google Earth, they'll disappear. But if you take them and drag them up here under My Places, I've actually got a folder called Global Geophysics, it'll save it for later. Okay, so it's loaded in the files, and so here's the KMZ file. If you expand it and expand it again, you can actually see all the different things underneath it. So this top one here is plate boundaries, so you can see these red lines are the boundaries of all the different tectonic plates. Seismicity I think is already on, but you can click it on again and you can see here's the scale. So if I zoom in, it means an orange dot here is an earthquake at 0 to 33 kilometers depth, and so forth. We'll look later at the deeper earthquakes. Here are volcanoes, so it's volcanoes around the world. Seafloor ages is the next one. So these are actually magnetic, these are the ages of the seafloor determined from magnetic stripes, which we'll learn about more in the lectures. So you can see the ages range from 0 million years to 180 million years in the oldest part of the seafloor. And then volcanic chains I think is just more volcanoes. Okay, and so these are the different things contained within the KMZ files. If you see big X's, it's earthquakes that haven't loaded properly, so don't stress about that. So yeah, let's take a look at the PDF for your tutorial. So the first thing in the PDF on the right hand side here says just describe something cool that you see on the Earth's surface. So yeah, absolutely anything you find, and it's good to start investigating now because for your final essay you're going to pick some part of the globe and write about it in relation to all the different topics that we learn. So if we're going to learn about earthquakes, you're going to write about what type of depth earthquakes are in that area. So start having a look now. If your world gets a bit wonky, you can just double click on the north arrow here and it kind of brings it back. So here we've got Africa, obviously we down here. You've got the Middle East over here, you've got Europe up top, you've got Russia and the rest of Asia. And then tectonic plates get very complicated here over Indonesia and Philippines, and going down here into Australia, and then we've got New Zealand as well. And where's America? So here, if you're not feeling dizzy already, is South America. There's a big subduction zone on the west coast, and then we move into North America here. So start looking around. Maybe something piqued your interest when you were younger or studying a different topic. You can come back now and investigate it in more detail. But yeah, many of you told me very interesting things here. In terms of topography, question 2 says, are the mountain ranges randomly distributed on the continents, or do they tend to occur in particular patterns, clusters, chain, or linear chains? So you obviously have to click off seafloor ages here at least to see topography, and I don't take for granted that many people haven't always used Google Earth, especially if you haven't studied geology. So you might say to me, well, how the heck do I know what a mountain range looks like? Which is completely understandable. And the easiest thing to do is to go to South America here, and you can see the greens here are the low-lying areas. So you've got the Amazon rainforest, whereas on the west coast here you've got the Andean mountain range, and so you can see it's these browns and whites is where there's snow on top of it, and you can see all of these volcanoes along the left here. So in general you've got greens being like flat grassy plains, and then the mountains, because they very often don't have lots of vegetation, are these browns and whites. So if we look in Africa, I mean here in Namibia it's not really topography, it's actually deserts, and this up here in the north is desert. So it's not always the right answer, but if we go here, so here we have Asia and India colliding with each other, forming the Himalayas, which is where you've got Mount Everest. If you zoom in, you can see there's not as much greens, and there's a lot of white here with the snow-capped peaks. So in general, that's a good way of finding mountain ranges. And so they do form these linear belts here. Here's your Himalayas. You've got the Alps in Europe here. I don't know how easy it's going to be to see. It's quite green. Here your Alps here, so you can see snow-capped peaks. And again, like I said, on the west coast of South America, whoops, you've got the Andes here. So it is these belts or these chains. And you'll see as we go through that it's linked to these plate boundaries. It's where very often you've got two plates colliding with each other. So they're converging. So it's called a convergent plate boundary. So that's where you're finding these mountain ranges. So Mount Everest is about 8 kilometers high. That would be question 3. But we don't just have topography on the continents, we also have topography on the sea floor. That we obviously just don't see because we see sea level. So it says here for question 4 to draw a profile from South America to Africa. And so you might have thought originally when you were younger that this is a flat sea floor, but there's actually topography down here. So if you're not sure what it looks like, you can actually look on Google Earth. So I'm going to zoom out here and I'm going to draw a profile. So I go to this button up here, Add Path. I click on it. And this window comes up. I can call it something. I'm going to call it Mid-Ocean Ridge because that's what we're looking at. I'm not going to close it because I have to click at on the Mid-Ocean Ridge before then. So I'm going to click here on South America side, click a few times across, and it's across this red boundary, which is a Mid-Ocean Ridge, which hopefully you learnt in school if you haven't done geology since then. But it's literally where two plates are moving away from each other. Sorry, that sneezes my daughter. And you can click OK. And you can see it's added this profile down at the bottom. It's going to add it, I think, wherever your mouse was clicked in this menu bar on the side. So it might have added it under temporary places. So once it's added here, you're going to right click on it and you're going to go Show Elevation Profile. And it takes some time to load the elevation profile. And if you're having problems, and this is a straight line, there's two things you need to check. You need to make sure that terrain is checked at the bottom here. You can also go to this profile, right click, go Properties, Altitude, and make sure here that, I'm not 100% sure, so mine says clamp to ground and it's working, but sometimes you have to play with the other options for it to work. Sorry, I've lost my profile. And so this is showing us what topography looks like under the ocean. So here, well, let's actually double check. As you drag your mouse over here, click and drag, it shows you where you are in the profile, which is great. So this is South America on the west, Africa on the east, and you can see that 0 here is the sea floor. So this is obviously a topographic high on the sea floor, and you'll see it correlates with this region. This red line here, which we said was where the plates are breaking apart. So we've got the African plate on the right hand side, South American plate on the left hand side, and they're literally splitting. And it's this detailed ridge here. So it's not just one little bump, it's actually quite a complicated ridge here. So this in the middle, approximately here, is where the main part of the ridge is. You can see it's the highest topography. So you can draw that in here. It goes down, it's going to rise up, and it's going to go down again. So that is called a divergent, which means they're splitting apart, plate boundary, and it's at the mid-ocean ridge. So there's a ridge in the middle of the ocean, and that's where it's splitting apart. The next question here says, if you've got South America, so let's just see, some of the lowest spots aren't in the middle of the ocean. Where are they? So here we're in the middle of the ocean, we've got a ridge or a high point. Well, where are the low points in the ocean? So it says, focus on the west coast of South America. So let's do another profile here on the west coast of South America. And I'm going to put here trench, because that's where we find trench. Well, we're going to find a trench here. And so I'm going to go from the ocean onto the continent. And I'm going to click OK. You can see it's loaded here. I'm going to right click, Show Elevation Profile. It takes a while to load. You can see originally there wasn't much detail. Now it's quite detailed. Again, as I drag along here, you can see where we are. We're getting to this darker blue area here. So just before this west coast of South America, we're hitting a trench that's going down to minus 7,000 meters. And it's a 7-kilometer deep trench. Then we're going onto the South American continent, and we're getting this high topography of the Andean mountains, and there's a lot of volcanoes here, you can see in red. And then we're getting to the more flat topography on the eastern side of South America. So you could draw that in here. It's obviously going to be flat, and then it's going to give us trench, and then South America. This region here, I'm wondering what's happening. There's a bit of a high here. I don't think it's a mid-ocean ridge, but there's definitely something going on in the seafloor here. But we won't look at it in detail. This question really just wants this profile here from in the ocean, through the trench, over this high topography. Here's this high topography in South America.